AI is like changing everything, right? But get this, it's even shaking up something as complex as computer chip design.
Wow.
We're talking about this system called AlphaChip
Oh, yeah.
from Google DeepMind, and it's designing chips like faster and better than humans can.
Really?
It's already being used in Google's own AI processors and even been adopted by other companies,
Interesting. Like who?
like MediaTek.
Oh, wow.
But there's a twist.
Oh.
There are some, serious questions that have been raised about AlphaChip's claims.
Like what?
Accusations of fraud, even whispers of a whistleblower.
Oh, this is juicy.
So buckle up,
Okay.
because we're about to take a deep dive into the world of cutting-edge tech AI and a whole lot of scientific drama.
I am buckled.
Okay, let's unpack this, starting with AlphaChip's rise to fame.
Okay. So AlphaChip really, took the world by storm.
Yeah.
I mean, imagine trying to design a computer chip.
Right.
You're essentially, placing and routing billions of transistors.
Yeah.
Those tiny electrical switches on a piece of silicon.
Right.
And you're trying to optimize everything for performance, power consumption, and size.
Yeah.
It's, mind-bogglingly complex.
Yeah, it sounds super complicated.
Even for, the brightest engineers.
So how did AlphaChip crack the code?
Well,
What makes it so special?
it uses a type of AI called reinforcement learning,
Okay.
which is basically training an AI agent through trial and error.
Okay.
Kind of like teaching a dog new tricks with rewards and penalties.
Right.
In this case, the AI agent learns to design chips by experimenting with different layouts and getting feedback on how well they perform. This approach allowed AlphaChip to surpass human experts in several key areas,
Wow.
particularly in finding efficient layouts that minimize power consumption and improve performance.
Makes sense.
Yeah.
Well, no wonder it got published in Nature
Yeah,
and sparked so much excitement in the field.
for sure.
But then the controversy hit. Enter Igor Markov and his meta-analysis,
Oh, yeah.
critiquing AlphaChip's claims.
Right. Markov used some strong words,
Yeah.
accusing the AlphaChip team of questionable practices, cherry-picking data, and even misrepresenting results. However, he didn't offer concrete evidence to support these claims.
Oh, really?
He even pointed to an alleged whistleblower within Google.
Oh.
But even this individual admitted to having no proof of actual fraud.
So where did Markov's critique get its substance from?
Well, he heavily relied on a paper by Cheng et al., who claimed to have reproduced AlphaChip but got very different and less impressive results. This is where things get interesting.
Okay.
To understand the core of this controversy, we need to examine the flaws in Cheng et al.'s methodology.
Okay.
Because if their reproduction of AlphaChip wasn't accurate,
Right.
then their entire argument kind of falls apart, wouldn't you say?
Absolutely. Let's dive into those flaws because
Okay.
I'm already sensing some potential issues here.
Okay.
Where do we start?
Well, the most glaring issue is that Cheng et al. Didn't pre-train their AI model.
Okay.
Remember how AlphaChip uses reinforcement learning?
Yeah.
Well, the learning part is crucial.
Right.
The AI needs to be trained on massive amounts of data to develop an understanding of chip design principles. Skipping this pre-training step is like evaluating a chess AI that's never seen a chessboard before.
All right.
It's simply not going to perform well.
Okay, so they messed up the training. What else did they get wrong?
It gets worse.
Oh, no.
They also use significantly fewer computing resources than the original AlphaChip study.
Oh, wow.
About 20 times less, to be precise.
That's a lot.
Imagine trying to run a complex simulation on a basic calculator instead of a supercomputer.
Right.
You're not going to get very far.
Yeah.
And as if that wasn't enough, they didn't even train the AI to convergence.
Convergence.
Yeah.
What does that mean in this context?
So in machine learning, you train a model until its performance plateaus. It's like training for a marathon. You push yourself until you reach your peak performance, Chang et al. Cut the training short, which basically guarantees that the AI won't reach its full potential.
Okay.
So even before we look at the specifics of their results,
Yeah.
we're already seeing some major red flags in their methodology.
It sounds like they were setting AlphaChip up to fail from the very beginning. What about the benchmarks they used to evaluate the AI?
Ah, yes, the benchmarks.
Yeah.
That's another problem. They used benchmarks that were outdated
Yeah.
and not representative of the kind of cutting-edge chips AlphaChip was designed for. It's like testing a race car on a dirt road instead of racetrack.
Okay.
Yeah.
So we're talking about like a flawed study on multiple levels. But given these methodological issues,
Yeah.
how much weight should we actually give to Chang et al.'s conclusions?
That's the key question. Their study raises more doubts about their approach than it does about AlphaChip itself. It highlights the importance of carefully considering the methodology and potential biases when evaluating scientific claims,
Right.
especially in a field as complex and rapidly evolving as AI.
All right. We've covered the pre-training, the
Right.
computing power,
Yeah.
the lack of convergence,
Yeah.
and the questionable benchmarks. But I'm guessing there are even more problems with Cheng et al.'s study.
Oh, yeah.
Where do we go from here?
Well, next we need to look at the specific comparisons they made and how those comparisons further highlight the problems with their methodology.
Okay.
And that's where things get even more interesting.
Oh, I can't wait.
Yeah. One of the most questionable aspects of Cheng et al.'s approach is their comparison of AlphaChip to closed-source commercial auto placers. These are essentially black boxes,
Okay.
proprietary software used in the industry.
Right.
So we don't even know the details of their algorithms or how they were developed. It's not exactly a fair comparison, wouldn't you say?
Yeah, it's like comparing apples to oranges. Or maybe even apples to like a mysterious fruit salad where we don't know the ingredients.
Exactly.
But why would they make that kind of comparison in the first place?
It's unclear, but it certainly raises questions about their intentions.
No.
And it's not the only instance where their methodology seems designed to put AlphaChip at a disadvantage.
Really?
They also conducted a so-called ablation study where they deliberately introduced a flaw into AlphaChip's process to make it perform worse.
What?
The original AlphaChip authors had already shown that this step was unnecessary. So it seems like an odd choice to include it.
Yeah, so they're essentially saying,
Yeah.
we broke it and now it's broken.
Right.
That doesn't seem like a very scientific approach.
Right.
Is there anything else that stands out to you as particularly problematic?
Well, their analysis of the correlation between proxy cost and final metrics is quite misleading.
Okay.
They claim to have found a weak correlation,
Right.
implying that AlphaChip wasn't effectively using these proxy costs to guide its design process. However, their own data actually shows a positive correlation,
Really?
even if it's not extremely strong,
Okay.
which suggests that the proxy cost is working as intended.
Can you back up a bit?
Sure.
What exactly are these proxy costs?
Yeah.
And why are they important in this context?
It's a good question. Proxy costs are essentially like intermediary measures that help guide the AI towards its ultimate goal.
Okay.
Think of it like using word prediction to train a language model.
Right.
The AI isn't directly rewarded for generating grammatically correct sentences,
Right.
but it learns to predict the next word based on the context,
Yeah.
which eventually leads to better sentence generation.
Okay, so in chip design, the proxy cost helps AlphaChip learn how to create better layouts,
Exactly.
even if it doesn't have all the information about the final chip performance right away.
Exactly.
Right.
And the fact that Cheng et al.'s study actually showed a positive correlation,
Right.
even if it was weak,
Yeah.
suggests that AlphaChip was indeed using these proxy costs effectively.
Okay, so we've got the questionable comparisons, the ablation study that seems designed to make AlphaChip look worse,
Uh-huh.
and the misinterpretation of the correlation data.
Right.
Is there anything else we need to unpack before we move on?
Well, there's one more claim we need to address.
Okay.
Their assertion that Google engineers validated their findings.
Uh.
This simply isn't true.
Oh, really?
What actually happened is that the Google engineers confirmed they could run a simplified version of AlphaChip based on the open source code.
Okay.
But that's a far cry from validating the full methodology and conclusions of Cheng et al.'s study. In fact, the Google engineers even provided feedback to Cheng et al.
Oh, wow.
About flaws in their approach. Feedback that was ultimately ignored.
So they're twisting the truth to make it seem like their work has more credibility than it actually does.
It seems that way.
That's pretty concerning,
Yeah.
especially when you consider the importance of transparency and rigor in scientific research. Speaking of transparency, didn't you mention earlier that AlphaChip is fully open source?
Yes, and that's one of the most important aspects of this entire story.
Yeah.
The AlphaChip team went to great lengths to make their work transparent and accessible.
Okay.
They spent over a year collaborating with the TensorFlow agents team at Google to ensure that every line of code was publicly available.
So anyone could scrutinize their work,
Yes.
replicate their experiment, and even build upon their code.
Exactly.
So there's no hiding the ball here?
Yep.
Everything is out in the open.
It is.
Which makes Cheng et al.'s lack of transparency even more perplexing.
It does.
Didn't they also criticize AlphaChip for using proprietary data?
You're remembering correctly.
Yeah.
And it's quite ironic, isn't it?
Yeah.
They criticize AlphaChip for using proprietary data, but then turn around and do the same thing in their own study.
Wow.
They claim to have used open test cases, but refuse to share the necessary information for replication when asked by the AlphaChip authors.
So much for transparency and open science.
Right.
It really undermines their entire argument.
It does. It casts a shadow of doubt over their claims and motives. This entire situation really highlights the importance of reproducibility and transparency in scientific research,
Yeah.
especially when dealing with complex and potentially controversial topics like AI.
Right.
If you're going to accuse someone of lacking reproducibility, you better be prepared to meet those same standards yourself.
Okay, we've spent a lot of time dissecting the flaws in the critique of AlphaChip.
We have.
But I think it's important to step back and ask,
Okay.
despite this controversy, is AlphaChip still a big deal?
Absolutely.
Mm-hmm.
Despite the unfounded criticisms, AlphaChip remains a remarkable achievement.
So we've established that the criticisms leveled at AlphaChip were shaky at best.
Yeah.
But does this whole controversy tell us anything about, the potential pitfalls of AI chip design? Or the challenges of evaluating these kinds of complex AI systems in general?
That's a great question. It really gets to the heart of why this deep dive is so important.
Okay.
The AlphaChip story is more than just a scientific dispute.
Right.
It's like a glimpse into the future of AI and its impact on critical industries.
So what are some of the key takeaways here, aside from the fact that we should always scrutinize scientific claims,
Right.
especially when they're making serious accusations?
Well, for one, it highlights the incredible potential of AI to revolutionize even most complex engineering tasks.
Yeah.
AlphaChip's success, despite the controversy, shows that AI can tackle problems that were once thought to be the exclusive domain of human ingenuity.
It's kind of mind-blowing when you think about it.
Yeah.
AI designing the very chips that power AI.
Right.
It's like something out of science fiction.
It is.
Yeah.
But it also raises important questions about how we evaluate and validate AI systems, especially when they're being used in critical applications like chip design. The traditional methods of peer review and scientific debate may need to evolve to keep pace with the rapid advancements in AI.
So we need to be more careful, more rigorous,
Mm-hmm.
and maybe even a little bit skeptical when it comes to evaluating claims about AI breakthroughs.
Exactly. We can't just take things at face value.
Yeah.
We need to look under the hood, understand the methodology, and consider potential biases.
Right.
Especially when those claims are coming from sources that might have vested interests.
That makes sense. But what about the broader implications of AI in chip design? Are there any potential downsides or limitations to this approach?
Well, one concern is the potential for job displacement.
Right.
If AI systems can design chips more efficiently than humans,
Right.
what happens to the engineers and designers who currently do that work?
It's a valid concern. AI automation is a topic we hear a lot about these days,
Yeah.
and it's something we should definitely be paying attention to as these technologies continue to advance.
Absolutely. And it's not just about job displacement. There are also concerns about the concentration of power in the hands of a few companies that control these AI technologies.
Yeah.
If a handful of companies are designing the chips that power everything from our smartphones to our self-driving cars,
Yeah.
that could have significant implications for innovation, competition, and even national security.
So it's not just about the technical advancements.
Right.
It's about the social and economic impact of those advancements.
Exactly.
It's a lot to think about.
It is, and that's why it's so important to have these conversations.
Yeah.
To engage in open and informed debate about the potential benefits and risks of AI.
Right.
We need to be proactive, not reactive, in shaping the future of these technologies.
I completely agree.
Mm-hmm.
So as we wrap up this deep dive, what's the one key takeaway you want to leave our listener with?
I think the biggest takeaway is that the future of AI chip design is incredibly exciting.
Yeah.
But it's also complex and full of potential challenges.
Right.
We need to approach these developments with both enthusiasm and a healthy dose of critical thinking.
I love that enthusiasm and critical thinking.
Wow.
A perfect combination for navigating the uncharted waters of AI. And speaking of navigating, I think we've given our listener plenty to ponder today.
Yeah.
They've gotten a crash course in chip design, a glimpse into the power of AI, and a front row seat to a real-life scientific controversy.
It's been quite a journey.
Yeah.
And hopefully they've come away with a deeper appreciation for the importance of transparency, rigorous methodology, and open debate. in the scientific process.
Couldn't have said it better myself.
Thanks.
So, to our listener, thank you for joining us on this deep dive. We encourage you to continue exploring the fascinating world of AI and chip design, to ask questions, challenge assumptions, and maybe even contribute to shaping the future of these transformative technologies.
I agree. It's an exciting time to be involved in this field.
Yeah, it really is. Until next time, keep exploring, keep learning, and keep diving deep.
And keep thinking critically.
Absolutely.